Alright guys, welcome back. So today we are going to go ahead and start with 10.6, and our goal is to use segments of chords, tangents, and secants. Before we go ahead and start with the 10.6 lesson though, I did want to go over what we did last time. And so there's this really nice put together organizer that I was able to find online for you guys, and it's circle angles graphic organizer. So all of this is stuff that we've learned from the beginning of the chapter, and then once we turn it over, then that's where we're going to find the stuff that pertains to 10.6. So just a quick overview. So the central angle here's a picture that demonstrates the central angle. It is the angle here, right, that is in relation to the arc as well. So the angle is equal to the arc. But again, that is only a central angle. And the central angle, as you guys remember, the sides are given by the two radii of the circle. Again, for this one, the angle is equal to the angle of the arc, which is a formula given here on the right. Then we learned about the inscribed angle. And so this one was when we see a circle with the angle given by two chords. And again, in this case, the chords are not the radii, but they are just any chords on the circle. And here, the angle is equal to 1/2 of the measure of the arc. So in this case, the angle x would be equal to 1/2 of 120. Okay? Later on, we learned about the vertex inside. So this was last lesson. We learned that in order to find this angle here, we would go ahead and add the two arc measures, which were on the opposite sides of each, and then we would divide by 2. So here, this is the formula they gave us. Angle equals 1/2 arc plus arc. It doesn't matter which arc you choose, because you're summing them and then you're dividing by 2. Then we moved on to the vertex outside. So in this case, when the vertex is outside of the circle, we go ahead and subtract the two arcs and then divide by 2. So the formula given is angle x is equal to 1/2 of arc minus the arc. Okay, and this arc is always the larger arc minus the small arc. The larger arc minus the smaller arc. Okay, so then now we're going to go ahead and review these other circle segments and lines. So for these, some of these we have covered and some we haven't. For example, this one we already saw before, and then some of these are new to us. This one we saw it as well. Everything else pertains to 10.6. So for this one, we have two tangents, we have a picture, and the formula or the relationship given is that these two tangents are equal to each other. So in this case, tangent equals tangent. 2x plus 1 equals x plus 10. And then that's how you would solve for x. For the next one, we have tangent and radius or diameter. In this case, we were given, this is the radius, and then this is the tangent. Okay, so the tangent and the radius / the diameter are perpendicular. So that would be the relationship between this radius and that tangent. So I'm just going to go ahead and write perpendicular. Okay. And I'm going to go ahead and draw a little right triangle there. So then this is something new, and that this pertains to 10.6. So this is actually part of today's lesson. And I really like how they have it here. It's very simplified and it gets to the point without trying to give you too much information and then just confuse you. So here we have two secants again, and then the relationship here, the formula is we have, in order to find one of the variables, we multiply the whole thing times the outside, so this is the whole thing, and then this is the outside here, just 3, equals to the whole thing, so in this case it would be 2 plus x, or times the outside, which would be 2. So I'm going to go ahead and write those out for you. So we have, again, for this one, we had the whole thing, which was 10 times the outside, which is 3, equals the whole thing on the other side, or the other secant. So it's x plus 2 times the outside, which is 2. Then in order to solve for x, we would go ahead and multiply this side, distribute the 2, so 2x plus 4. Subtract the 4 from both sides, and you get 26 equals 2x. Divide both sides by 2, and then you get x equals 13. Okay? So again, for this 2 secant part, you multiply the outside, or the whole thing times the outside equals whole thing times the outside. Now be careful not to multiply these two numbers. We're not multiplying, we are adding them. Okay? So now we're moving on to secant and tangent. In this case, this is our tangent and this is our secant. And we have a whole times, actually, sorry, we're having this is the whole times the whole. In this case, it's just x times x equals the whole thing times the outside. So here we're going to have x times x equals, again, 4 plus 6 equals 10 times the outside, which equals 4. Then I'm going to go ahead and multiply x times x is x squared equals 10 times 4 is 40. Then I'm going to go ahead and take the square root of that. X equals, well, I know the square root of 40 is, I could do 8 times 5, and then I could break this further into 4 times 2 times 5. Now I know the square root of 4 is 2, so it would be 2 square root of what's left inside. In this case, 2 times 5, which is 10. So my simplified answer would be 2 square root of 10. Okay? And then finally, we move on to the two chords theorem. And so we have piece times the piece equals piece times piece. So I think this is going to be the easiest one for you guys because you're just looking at the individual parts. So we're doing x times 2 equals 4 times 3. And then it doesn't matter the order, right? Because you're just going to go ahead and multiply them anyways. So it could be either or. Then we have 2x equals 12. You divide both sides by 2 and you get x equals 6. And there you go, guys. All right, so this was pretty much it for 10.6. Now I really liked, again, how they gave us the information without overcomplicating it. And so instead of going by the book, I decided I'm gonna go ahead and try this way, and then I think it'll still you're still getting the meat of everything, and it's not too much. So we're gonna go ahead and do some examples in a bit. Okay.